Good morning, students. Today we are going to discuss about dimensions of a physical quantity. What is meant by dimension? Dimension is defined as the exponents to which the fundamental quantities are to be raised to represent a given physical quantity. We already discussed there are 7 fundamental quantities, and based on 7 fundamental quantities all the other derived quantities can be made. So what here the definition means is how we have to multiply or divide a fundamental quantity to get a derived quantity. That is why they told like this: the exponents to which the fundamental quantities must be raised. That means in powers of 10. Exponents means the powers of 10. Whether it is length is multiplied twice, so it will be L into L square. If mass is multiplied thrice, then it will be M cube. Like that, how much the exponent of the fundamental quantities have to be written to get a derived quantity. That is called dimensions. So I am just giving you a table which shows the basic dimensions of the fundamental quantities. See, always the dimensions should be written with a square bracket. Dimension of mass is capital letter M with the square bracket. Dimension of length is L, and dimension of time is T. Dimension of current is ampere, A. Dimension of temperature is K. These are the 5 things we used: mass capital M, length capital L, time capital T, current capital A, and temperature capital K. These are the 5 things we commonly use. And apart from that, amount of substance, you already know amount of substance and luminous intensity. Those 2 are the basic quantities. If that quantities comes, then you can write mole in the square bracket. That is the dimension of amount of substance. You can write mole in the square bracket. Similarly, if they ask luminous intensity, you can write candela, CD in the square bracket. Okay. So these are the basic dimensions which we are using. Now let us see how to find the dimension of a physical quantity. So I will first go with the basics, and we have studied many equations in class 9. I will go with the equations which we studied in class 9 and class 10, and we will obtain the dimensions. Okay, I will tell you how to find the dimensions, and then we will be doing the higher quantities of dimensions. Okay. So first one is area. Area is L length into breadth, right? Therefore I can say length into breadth which is L into B, but both are length measurements itself. So I will write L into L. L into L. So the dimension of area is L square. Okay. Now let us see the dimension of volume. Volume is length into breadth into height. LBH. So I just write the formula LBH, but all these are length measurement itself. Therefore L into L into L. That means L cube. L cube. So that is the volume. Now the third thing, density. What is the unit of density? Unit is kilogram per meter cube. And what is the formula for density? Mass by volume. So let me use the formula. Mass by volume. Mass is capital M. The dimension is capital M. And volume L cube. So if anything comes in the denominator, if any quantity comes in the denominator, we have to put it in the numerator as the reverse power. That means I will write this as m L raised to minus 3. This is the dimension for density. Now we will go for the fourth one, speed or velocity. Speed or velocity. What is the equation for speed? Yes, distance by time. Distance by time. That is the formula. Now, distance is length measurement, right? So I will write L, and time I will write T. So my answer is L T raised to minus 1. I think you got the basic idea, right? Now take the book and I'll be giving the questions and you can find the dimensions by yourself. All of you take the book. Acceleration. What is the formula for acceleration? Velocity by time, right? So v minus u by t. This is the equation for the acceleration, change in velocity by time. Change in velocity means it is a velocity. So we can write the dimension of velocity, that is Lt minus 1. And in the denominator again time is there. And this time will go up. Therefore, what will you get? Lt minus 2. Now you try for force. What is the equation for force? Yes, F is equal to m into A. Okay, try by yourself. Mass into acceleration. Mass we know it is capital M and acceleration is Lt minus 2. So when I club this, I will get mLt minus 2. Okay, now I'll give you one more. Work. Work is force into displacement. So I will write force into displacement. That's the formula. Now, dimension of force. We have found it here. mLt minus 2. That is the dimension of force. And d is distance. So we can write L. Therefore, you will get mL square t minus 2. This is the expression for the, this is the dimension for the work. Now, in 9th standard, you have studied work done is same as energy. So, if they ask any kind of energy, say for example, kinetic energy, potential energy, heat energy, anything. If anything related to energy is asked, the dimension of energy is same as the dimension of work. Therefore, the answer is mL square t raised to minus 2. Now, Next is dimension of pressure. I am not giving the final answer now. It is your part to find the final answer. I am just giving you the formula. Pressure. Formula is force by area. Force by area. You can find the dimension by yourself. Then power. Power formula is work by time. Find it by yourself. Okay. Then comes impulse. Formula for impulse is force into time. Get the dimension. Then comes momentum. Mass into velocity. So find these things by yourself. So we have studied 12 dimensions. The final answer for these 12, the first 12 things, the final answer you have to study by heart. Because, see, look at the 10th question, power. Equation is work by time. Only if you know the dimension of work, you will be able to find power. Similarly, see momentum, mass into velocity. Only if you know the dimension of velocity, you can find the direction of momentum. So like that, there are many quantities which I will be giving you now. But the first 12 dimensions has to be learnt by heart. And based on this first 12 dimensions, we will be moving on to the next higher sections of dimensions. Okay. Now let us see how to find the dimension of universal gravitational constant. Universal gravitational constant. It is capital G. In 10th standard, you have written F is equal to G m1 m2 by r square, universal law of gravitation. So I write the equation G m1 m2 by r square, and from here I want G f r square by m1 m2. Now let us put the dimension for each of them. So dimension of G is dimension of force, which is mlt minus 2. Dimension of r is radius, which is the length only. So r square, I will write L square. Then mass, m1 and m2 are masses, so m square. Now club all those things, take this m square top, it will be m raised to minus 2, and here there is m. So the final thing is m raised to minus 1, L into L square is L cube, and t raised to minus 2. So the answer for universal gravitational constant is m raised to minus 1, L cube, t raised to minus 2. I will show one more thing, Planck's constant. Planck's constant, it is H. Energy equation is H into nu, where nu is the frequency. E for energy, H for Planck's constant, and nu for frequency. Therefore, we can write H is equal to E by nu. Now let us find the dimension. Dimension of H. Dimension of energy. What is the dimension of energy? Yes, ml square t minus 2. Frequency is 1 by time period. Dimension of time is t. So dimension of frequency is 1 by t, that is t raised to minus 1. Correct. So t raised to minus 1. And take t raised to minus 1 on the top. So you will get t raised to 1 only. Therefore, the dimension will be m L square t raised to minus 1. Here t raised to minus 1, t raised to minus 2. They both cancel and you will get t raised to minus 1. So m L square t raised to minus 1 is the dimension for Planck's constant. So in this manner you can find the dimensions for different quantities. I'll show you two more quantities: potential difference and electrical resistance. Okay, we will do those two things also. Potential difference. Potential difference is V. We studied V equal to work by charge. Work by charge. And what is charge? Current into time. I is equal to Q by T. That is what you studied in 10th. So Q is equal to I into T. So work by IT. So let us see how to get it. Dimension of V. Dimension of work is m L square T minus 2 divided by I, current. Dimension of current is A and time is T. Take it up. So you will get m L square T minus 3 A minus 1. This is the dimension for potential difference. Okay. Now the last one, dimension for resistance. Capital R. You have already studied R is equal to voltage by current, potential difference by current. The dimension of potential difference we have already found on the top. So dimension of R will be m L square T minus 3 A minus 1 divided by I means ampere, A. So this A also will go up, so it will be A raised to minus 2. So our final answer will be m L square T raised to minus 3 A raised to minus 2. Okay. So in the exam, these many questions will be asked, and apart from that, there will be other questions also. So when we know the formulas, using the formula, you can find the dimension based on this way. Okay, we will see what are the uses of dimensions. Dimensions can be used in many aspects. So in the next class, I will be discussing what are the uses of dimensions. Okay, thank you.